All right, welcome back to the fifth page of the review. Now, at this point, we've skimmed through all of congruent triangles. We've even kind of skipped past similar triangles. That'll be a here and again in a minute, even though we learned that out of order. We're now at the most recent thing. We just learned proportional parts of similar triangles. So, assuming triangles are similar, can we show they are? Can we show they're not? That is the goal of what we're doing today. And then we'll do some proportions using cross multiply and divide. So, let's get into it. Turning the camera again. I still have no editing software. Sorry, guys. So, I'm going to start with these. Let's read the directions as we should. Any good student would. Let's see. The instructions say, state if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. So, what does that mean? First, we're going to check, are the triangles similar? So first, check if they're similar. If they are, state how we know. So like which method? Angle, angle, similarity? Side, 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 similarity? Or side, angle, side, similarity? Those are the three possibilities for being similar. We're going to compare each of these. Now, I circled a couple ones that I thought were like the most important. Really, since this is something we went over not too long ago, and we kind of had the weird gap day. I just wanted to go ahead and do a lot of these for us. So, anyway, sorry, my camera would focus. Thank you. Okay, so for this first one on number 9, I am thinking. It looks to me. I would like to check if these are similar. So it looks to me like I immediately notice these two form a vertical pair. So here at E, there is an angle now. So that is good because if these sides are proportional, we could use side, angle, side similarity. So it looks like I'm going to set up for side, angle, side. I'm just going to write that up here to remind myself, side, angle, side similarity. This is what I'm testing. So now I need to know, since I'm doing similarity, are these proportional? Are these sides proportional to one another? So I like to do mine big over big equals small over small. So I see big here, and then this side is actually bigger in this case. So the triangles, you can't really tell because the picture is hard, but the triangle, if you flipped it over, it'd be like tilted so that this side they're aiming towards each other this way. So these two sides are worth comparing in our proportion. So I would say 83 over 48. And now I'm asking myself, is that the same as, I don't know yet. I'm writing equals, but I don't know. I'm just testing it, so I'm putting a question mark to test it out. Is this really equal to 77 over 44? Now, there are a bunch of ways to do this. You could just put this right in your calculator. I'm going to use cross multiply, since that's what we do in a minute. You could just put these fractions in your calculator and see if they're the same ratio. Really, I just want to know if the proportion holds. So I'm going to use cross multiply, because that's my favorite. So 83 times 44 in the calculator, because I do not know that, is 3,652. All right, and I'm still testing. I don't know if they're equal yet. I guess I'll be able to see in just a second. So I'm about to see when I write this number down. But 48 times 77 is 3696. Now those numbers are kind of close. If you had divided them to see, like, let's see, 83 over 48. I get 1.72. If I divide 77 by 44, I get 1.75. Okay, so no. But I was saying, sometimes the decimals may be close, but then you cross multiply and they're pretty far apart. So in this case, we see these are definitely not equal. Since the proportion doesn't hold, this is what I'm thinking. Like the proportion, and I'm just going to write this you don't have to write this yourself, but the proportion doesn't hold. Okay, and for me, we know this means they are not similar. So I'm going to write not similar by side, angle, side, similarity. So, since the proportion doesn't hold, I know for sure these triangles are not similar. Now, it could happen that the triangles were similar, in which case you would write the similarity statement and finish it. But they weren't in this case, so I'm not going to finish it. Now, down to number 11. I'm going to skip 10, leave it for you guys, and try number 11. So number 11 down here, I immediately also notice vertical pairs going on here at angle here around the point D. So the angle VDU is obviously by a vertical, well, not obviously maybe, but congruent to angle EDF. by the vertical pair theorem. Great, awesome. That's one angle. Now, if I had one other, now I don't know anything really about the lengths of sides. So the only other way I could do something is if I had one more angle, I could aim for angle-angle similarity. So this is just me writing it down to remind myself. Like, when I see this problem, I'm thinking it's probably going to be angle-angle similarity because I don't really know anything about the other sides. Now what I can do, I see these lines aren't parallel. Everybody loves transversals. They always come back. So transversals here, I notice our favorite friend, the alternate interior angles, are hiding in here. So I'm going to use two lines, sorry, to show that they're equal to each other but not equal to D. All right, and as a result, by alternate interior, and that is what these are called. So you can see, and the little trick I gave you guys was look for the Z, right? Here's a Z, all right, and the corners of that Z make alternate interior angles. Anyways, so I would say, yes, there are two angles congruent. Angle holds. So just because we have two angles, those triangles are definitely similar. They must be the same shape. All right, and down here I'll say, but of course different sizes, they're scaled up. So it starts at D, goes to F, goes to E, then to F. So I'd have to start at D, go to V, then U. So D, V, U is the proper phrasing. Oh, I should say triangle. Triangle DVU. I thought the symbol was already drawn, so my bad. Triangle DVU, and that's the similarity statement. Maybe I'll rewrite it so that it's very clear. Triangle DEF is similar to triangle DVU. All right? You know you've written your mathematics correctly if it reads like a sentence. Triangle DEF is similar to triangle DVU. All right, beautiful. Now, quickly on to number 12, so that the video is not like 40 minutes long. We're going to try something very similar like we've been doing. All right, I see two triangles hiding in here, a small one here, KDE, the triangle KDE, and the big one here, the triangle KLM. All right, my goal is to show they are similar, so I'm going to try it. Now, I see the big triangle, this side is labeled as 27, but this side is not labeled. So to help myself out, the length of the long triangle I see is 8 plus 16, which is 24. All right, very cool. Now I'm able to compare proportions. So I'll do big to big and small to small. So 24 is less than 27, so it goes with 8 because it's less than 9. Okay, I now know I can test these proportions out. I'll say 9 over 27. Is that equal to, I don't know, is that equal to 8 over 24? And maybe you can tell as soon as you look at this. Yes, I look at this and I realize that these are both equal to 1/3. Now, if you didn't know they were both 1/3, that's okay. We can still cross multiply to check our answers, so I'm going to do that. All right? 9 times 24. Since cross multiply comes in handy so much down here, I'm going to cross multiply these because there's a fraction with an equal sign in between. All right? 8 times 27 is 216. And then 9 times 24 is 216. So the proportion holds. So I would say something like proportion holds. Awesome. Great. This means that triangle KLM is similar to triangle KDE, or KED, sorry. KED. And I'm going to say by side. Oh, and we didn't even realize there's not a third side here, but look, this angle is reflexively equal, so this is actually a side angle side similarity. Beautiful. Now, using proportions to solve algebra, we're going to try these two top problems, 31 and 32, quickly. All right. Now, I have a fraction expression equal to a fraction expression. That means I can cross multiply. So, I'm going to do just that. My first step is going to be b minus 9 times 3. Now, I'm multiplying 3 by b minus 9, by b minus 9. I want to multiply by the whole thing, though. So I'm going to use parentheses here. I'm not just multiplying by b or 9. I'm multiplying by everything, equals, and then 2 times 5 is 10. All right. Now I'll distribute my 3 out. So I have 3b minus 27 equals 10. All right. And then adding 27 to both sides yields 3b equals 37, and then b is 37 over 3 would be my answer. I don't know in the calculator. Let's see how much that is. It is 12 1/3. All right, this is a totally fine answer to me. This is a simplest form fraction, and I'm cool with that. I personally love fractions much more than decimals. If you want to write a decimal, though, that's fine with me. You can do whatever you want as long as it's mathematically correct. So Over here, same thing. I have a fraction expression equal to a fraction expression. I'm then allowed to cross multiply, so I'll cross multiply these sides. I see that x 3 times, and I want to multiply by the entire denominator. So I have to put this in parentheses, x plus 3 equals, and then 2 times 2 is 4. Now, we can distribute this 3 out to get 3x plus 3 times 3 is 9 equals, and then 4 on this side. I'll subtract 9 from both sides to get 3x equals minus 5, and the result would be negative 5/3. I think I made a mistake on the key. I accidentally reciprocated this. That's okay. It happens. All right. Our true result, the true answer is negative 5/3. So this is the correct answer for that problem. All right. Very cool. So if you feel good about this page, awesome. This is a classic mistake to make. Gosh, what am I trying to say? A classic mistake to make for students who take the test is they're going to look at this and then do something crazy with these fractions, guys. All we need to do is cross multiply and do algebra like normal. So keep that in mind as you move forward. I'll see you guys on the next video.